Hello everyone, welcome to the video, and today I'm going to show you a small project I did using a web framework called GoFiber. It's a Golang framework and is actually called AnyPaste. And the application is called AnyPaste because it's a cheap clone of Pastebin, if you're familiar with this service. And a user actually can submit any text and AnyPaste will store it in the database. And afterwards, the users can retrieve a specific piece of a posted text, providing its identification number. So let's get on with this video's agenda. First, we're going to explain how we split the project into microservices, right? And we're going to show the structure and the logic behind each microservice. And then because we're deploying this project on a Kubernetes cluster, we're going to go through some Kubernetes manifest files, okay? And then we're going to demonstrate how you can download and run the whole project locally on your Kubernetes cluster. Of course, you can modify the project or take an example from it and do whatever you want with it. It's just an example. I wanted to do this project because when looking over the internet for something similar, meaning that I wanted to see a project comprising of several microservices and deploying it on Kubernetes. I did not find something in particular that was very helpful, and I wanted to do this project to show to everyone else how to do it from scratch, go from zero to hero. So let's get started. First, I want to discuss briefly a few things about monolithic applications and microservices to understand why this is important. Why it's important to have your application deployed on a Kubernetes cluster, and this is important for applications which we want to scale to a certain degree. So a monolithic application is a single piece of code, a single code base that includes the user interface layer, the business logic layer, and the database interface layer. You use the user interface layer to get data from the user and forward it to the business logic part, which actually does call some other APIs or get some data from the outside world and makes a few calculations. Maybe is going to ingest some data to a database via the database interface layer or get some data from the database, do some calculations, and then forward the results and the data to the user interface layer, which is going to render the results and provide useful information back to the user. And usually we can see this kind of applications, meaning monolithic, being deployed on a single server, okay? And you have this piece of code on a single server running, and if you want to scale this application, you have to run another instance of this application. And why do you need to scale an application? Because you got increased traffic, right? Your application is going to develop and is going to grow, and you want to have lots of users, right? Because you're successful. And one solution is to run another instance of your application on a different server and then connect it to a database. But here you can see by yourself that the bottleneck is that you got to deploy the whole thing again. And it might be the case that only the business logic part is computing intensive, and you only need to scale this part of your application, or maybe only this part of your application. But instead, you have to clone the whole thing, and you're using resources that you don't need. Besides that, another solution is to upgrade your current server, and maybe you can use a server with more RAM or more CPU power, or even with a better graphics card, right? But this implies increased overhead and and expenses. So here we come to another thinking. How do we scale applications? A good solution is to break each part of your application into smaller services, into pieces of code that called microservices. And here you can see here in this example here, we have different service for the front end, which is, let's say, the user interface and the part of your code that renders data which forwards to the user. And you might have 1, 2, 3, 4, 5, whatever, how many you want backend services instances running together. And you might have not only a backend service, you might have here another authentication, let's say, service. You can have whatever you want actually, and you can split your backend into smaller microservices. But for the sake of this example, we're gonna use just 2 microservices, front end and backend microservices. And you might need for your traffic 2 instances of the front end to serve your clients, and you might need, let's say, 3 backend instances to do the whole computation. Another important thing that you might introduce into your architecture is a load balancer. Here you can see, which takes requests from the front-end microservices and forwards them to your backend microservices and distributes evenly the load. Okay, so you can process in parallel 3 different requests. You might have here in the front, in the door of your application, another load balancer to distribute evenly the request among the front-end instances. And you've got your database. This is something that won't change much here. So yeah, this is the logic behind microservices and monolithic applications, and why it's better to have microservices. As we said before, this is because you can scale each part of your application independently without having to clone the whole thing or upgrade your server and so on. And now we're gonna move towards describing what we're gonna do here in our backend example of our application AnyPaste, and we're gonna explain the logic behind frontend and backend before we proceed in showing you how they actually work and are implemented. Right? So the idea behind the backend is that you're gonna separate your software into 3 layers. You're gonna have the handlers layer, you're gonna have the data access layer, and then you've got your storage, which is actually database. And your backend is gonna receive get and post request. You're gonna receive get request to retrieve data from the database, a post, and you're gonna receive post request to create a new post in the database. And each handler is gonna receive this request and is gonna call the appropriate data access layer function or method. It's gonna be maybe a read or a write, I don't know, which actually is going to directly call the database to ingest or retrieve data. And yeah, this is it actually for the backend. It's pretty simple because we've got a very small and simple application here. And the same goes for the front end. The front end is gonna receive a get request from your browser, and it has to be a get request for rendering and retrieving the home page, where the user can input a text in a text box and then submit the post. And you're gonna have a get request for retrieving a specific post, right? So you're gonna have 2 types of get request, and you're gonna have handlers, and each handler is gonna handle different requests. For example, retrieving the home page and retrieving a post. And and for example, if this handler here is responsible for getting data from your API, from your backend, which lie on your database, it has to initiate an HTTP request through this handler, which will call your backend, as we've seen here. Your front-end service makes a call towards the backend service, which calls the database, retrieves data, data returned to backend, and from backend to frontend, and from frontend to the actual user. So this is it, the actual logic behind the my simple application here, AnyPaste. And next, we're going to walk through Kubernetes manifest files. Maybe we're gonna show a few methods and Go code, and then we're gonna demonstrate live how you can download and run the project on a local Kubernetes cluster. So let's go. And you can see here in the repository of the project, you can see you've got a folder backend. Here lies the code of the backend, and here lies the code of frontend, while in the K8s folder we've got the manifest file of each microservice. So let me just go through quickly the project microservices, and you can see here it's written using Go Fiber, a very nice tight framework of ability with Golang. And you can see here the door of your application is pretty simple. You create a new web service, and then we initialize the database and we set up routes, and the project and the instance of the servers runs on port 3000. So as you can see here, we've got routes. Routes meaning that these are the type of requests our application can get. It can get a GET request and a POST request, and the GET request is going to be handled by the read POST handler, and the POST request is going to be handled by the create POST handler. And as you can see here, I've got a folder called handlers. You can go in there, and as I said before, you got your handlers, which are functions that are going to take, for example, create post is going to take the the data from, it's going to create a new model. This model is a struct, let's say an object representing the data that describe a post, right? And we're gonna parse the data and marshal the data into the struct, and then we're gonna call our data access layer, the function create post, which is actually going to create the post on the database. And if we are successful, we're gonna return a bit of JSON string back to the user with the post ID and with the error null. And we're gonna set the status of the request to 201, which is actually that says that we have successfully created a new resource, and here is the resource. In case we got an error here, we're gonna return a 500 error, and in case the request is bad, we're gonna return a 400 error. Similarly, we got the read post handler, which is gonna get the given ID and is gonna go through the data access layer to the database, retrieve the data, and return the data with a 200 code. And as you can see here, we've got the data access layer as well with the aforementioned functions. You see here database.db.create and create your post, or database.db/.first, which is going to retrieve the first record with the given post ID. Also, you see here that we've got the database folder that we got our MySQL connection initiated here. We give the database user the database password, the database host, the database name, and our backend is going to initialize a connection to the database. What else? Let me show you here. I mentioned about having models, and in our use case we got the post model, which is actually a struct, and you got your post data, which is actually a string, and here we got a few referenced attributes that lie within the Go library. And actually this line here introduces 3 attributes, which are record ID, date created, date updated, date deleted, I think. What else we got here? And you can see here as well in this folder that we got the Docker file, which is actually the file created to build an image of the backend microservice, right? Likewise, we got the front-end project built in the same logic. We got the routes, the models, the handlers. We got an extra folder here, views, which actually includes HTML templates that are used to generate and render the response for the user. For example, here we retrieve using a handler a post from the backend, from the API, and when we render the result, we just replace here this variable with the actual retrieved data, because as you can see here in the handler, what the handler in the front end does is that in the first place, let's say the read post handler is going to generate and create a new HTTP client, is gonna call the backend. You can see here we've got the API URL, and we're gonna give the post ID as well. And when the JSON with the data is retrieved from the backend, we're gonna render the HTML file called post, and we're gonna replace the variable post within the HTML template with the retrieved data. And here, this is the create post handler. If you walk through the project on your own time, you will realize that here I'm using a different HTTP client than here. And you can see here that I've imported the net/http library from Golang, but I just used 2 different libraries because I wanted to show you that it's possible to initiate an HTTP request from the front end towards the backend using different libraries. Here I'm using the Go native HTTP library, while here I'm using the HTTP client that can be found within the Go Fiber framework, which is actually a wrapper. I mean, the HTTP client library is a wrapper for the fast HTTP Golang library. Perfect. And as you can see here, I say that you're gonna get the API URL from the environment, right? We're gonna include the API URL in the environment. And why do we do that? Because I don't want to hard code any endpoints in my project, because I might change something, I might add on something else, and it's very inconvenient to need to build again and again the Docker image and upload it to a Docker registry where it can be found and downloaded, right? I want to be parameterized, and each time I deploy the whole project somewhere, maybe on a Kubernetes cluster, I want to take the location, the address, the URL of the backend from an environment variable that is injected right there. And let me show you where you can see these variables. As you can see here, I've got a few manifest files, and if you go to the website, you can see here in my deployment file that, oh, not this, maybe is here, no, let me take a look again. Oh yeah, here it is. You can see here that I declare the environment variable called API URL, and this is its value, and you don't need to alter your code every time you change the endpoint. You just declare the new endpoint in your Kubernetes manifest file, which is much easier to edit and deploy, right? And once we're here, I'm going to show you that the manifest file for the website service, for the deployment of the website, says here that is going to run in container, that is going to take the image from this location, which is actually my Docker Hub registry, where I host the images of the microservices of AnyPaste. And if you can go here, you can see here, let's say Docker Hub. You can see here that I have already uploaded ready images to be used. You don't need to build the project again. You can see here this is the image for the front end, the website, and this is the image for the backend, the API. And yeah, Kubernetes is going to retrieve the image from there and then deploy it. And besides the deployment file, we got a service file, which is actually how we're going to publish the API, the container running the API in a Kubernetes network. Each running instance needs a service to enable communication with other instances and services running on a Kubernetes cluster, right? And each workload, each deployment is going to run within a pod. A pod is a wrapper of a container. You can imagine it as a pod as a container, maybe. And what else we got here? We got here the API manifest files. As you can see, we've got a deployment file as well. We say here, this is the image we want you to run, and it's going to retrieve it from the internet and deploy it. And here I declare a few other environmental variables, such as the database host, DB port, DB user, DB password. To be honest, here this is not a good practice, to be honest, to inject this kind of information within the deployment file. It's better to encrypt and host these kind of configurations maybe within a configuration file of Kubernetes, or a secret Kubernetes secret, or maybe you can host these values within a key vault and dynamically inject the values on runtime. But for demonstration purposes of this project, I just injected the files here, the values here. And you can see here we define the port number running the container. We can define the resource limits that we're gonna provide to the container. And again, we got the service to make it visible to the whole Kubernetes cluster, right? And as you can see here, I created another folder named database. To be honest, it is not a good practice to deploy databases on Kubernetes. This is not the purpose of Kubernetes. Kubernetes purpose is to host maybe stateless instances of an application, while a database has a different logic behind it, has its own logic for replication and distributing requests and workloads. They should run outside of a Kubernetes cluster, but for the sake of this example, we're going to deploy a database on Kubernetes. So I created these manifest files here that I found with the help of the internet, and you can walk through them alone if you want. I just use them here just to have a database, because you need a database to make this thing work. And finally, we got the ingress.yaml manifest file, which is actually a file describing how we're going to handle income traffic, because you have services running on your cluster, but they are not visible from the outside world. you need to have a gateway. You need to have a door for a request to be routed through your application. Each and every microservice running on your application right now, in our case we have a front end and the back end, is not visible from the outside world. So we create this file here that describes that every request that comes with the path, the prefix path slash, is going to be routed to the service website. So your backend is not going to be visible from the outside world. It's going to be in a private network within the cluster, and only you can communicate with it using an intermediate, which is the website, right? And it's running, and this ingress manifest file, ingress resource is destined to be run on an Nginx load balancer. And the Nginx load balancer here, if you remember from before, we showed that you might have a load balancer in the door, in the gateway of your application. It's actually called an ingress controller. A load balancer can be called an ingress controller in terms of the Kubernetes terminology, right? What else? Actually, this is it. I'm going to just run the whole thing for you to see that's working. You need to have locally installed Docker Desktop or Minikube if you are on Linux, which simulates a small cluster with one node. I have already installed on my Mac environment here Docker Desktop, and as you can see here, if you go to settings, Kubernetes here, you can see that there is an option to enable and run Kubernetes via Docker Desktop. And this is what I'm doing here. Actually, I'm running Kubernetes service in my on my local environment, and you can access and see what's inside your Kubernetes local clusters using different programs. Here I'm using a really sweet and with very good visuals application called Kubernetes, which actually helps you to connect on different clusters and see the namespaces of each cluster and what workloads you have installed on the cluster. So here I'm connected to the Docker Desktop cluster, and you can see here there is nothing running. There are no pods, no deployments on on this cluster, and we're going to create them right now. So I'm gonna leave this on the side for a while. So first of all, I'm going to download the project here. So I'm on my desktop, git clone application, cloning, perfect. And the next thing we're gonna do, you also need kubectl, which is the CLI command line tool that enables you to communicate with your cluster and give it instructions and read data from it. So the first thing you do is create a namespace. We're gonna create a namespace called anypaste. Namespace created. Then we're gonna just deploy the database. Sorry. We need to get in the repository first. So for that, we create a volume. It's like a Docker volume for saving your data. And then you create a secret, then you create a configuration. Alright, then you create the deployment, and then you get your service. So your database will be visible from other services in the cluster. Perfect. And as you can see, if I open here my Kubernetes visual dashboard, I can go to here namespaces. Here is the created namespace. You can see here that we've got a pod already running, which is our MySQL pod. we can connect on the pod via here, and if you write mysql -p, enter the password, you can see here show databases. Voila, we got a database here. The first time you're gonna run this, you won't have this database here called DB, but you should have it. I have it here because I already created it before filming this video. So if you want to create it and you need it because your backend API is going to look for a database called DB, you can write here create database DB semicolon, press enter, and it's going to be created. But here we got an error because it already exists. So I'm going to exit by says next we need to install the backend. Copy and paste, and then the backend service, copy and paste. Oops, any past, wrong, here is the correct, and then front end, and then the service of the front end. Perfect. And we can see here three pods running, and we've got also 3 services running. This is the internal cluster IP of each service, and as you can see here, we've got an external IP which is none, meaning that any service running on your cluster is not accessible from the outside world. And yes, next we need to deploy the ingress file, but before you do that, you need to enable the ingress controller, which is actually an Nginx instance, as we said earlier. And you can do this on your local Docker desktop on Mac using this command, or using Minikube add-ons enable ingress on your Minikube cluster. I'm gonna run this command here. I think I've already done it, but just to be sure, I'm gonna run it again. No, I've not done it before. As you can see here, everything is created right now. And you can see here there is a new namespace ingress nginx, and it's pending for an external IP address. Okay, and finally you just deploy your ingress. And if we go back here to our AnyPaste, I think we're gonna see here in ingress that we have created a new ingress, and everything that comes is forwarded to the load balancer here. Ingress services. Here is pending, is trying to generate an external IP address, but it might take a while. I hope it won't take much. I'm gonna pause the video until this comes up. My laptop is running loud, and I will come back to you later with the final product. And sorry for the delay, but apparently my Docker desktop got stuck, and actually the external IP did never come to my Kubernetes cluster, so I restarted the whole application, and as you can see here, we get an external IP which is localhost. And if we go in your browser and press localhost, you can see here that you get the application, and you can write whatever I want, like for example, I like hot tea, and you can see here there is a response. Here is your ID of the new post, which is 1, and if you come here and write /post/1, press enter, you can see here you retrieve the text you just paste, which is like hot tea. And if we go back in our Kubernetes dashboard and go to our website pod, for example, and view the logs. No, this is a service. Sorry, pods, website logs. You can see here that we've logged all the requests, right? And the same happens for the API logs. Maybe not, but yeah, you get the idea. Everything works, everything's fine, and thank you for watching, and bye bye.